Okay, so today we're getting into ocean energy. So we're interested in ocean energy because ocean has heat. Okay, so that's your thermal and also mechanical energy. So for heat, your thermal energy from ocean, we can get it from the mass of that water in the ocean and also the temperature of the water. Okay, all of you, I think you might remember ocean as a very cold, right? But it isn't. Yeah, we can be able to get the heat out of the ocean. Easy because you know that the waves they have force, tremendous force. Okay, and we call that the tidal actions. So the tidal waves, like tsunami, can knock the houses right off of the beach, and also mess with all the towns along the coastal line. Yeah. So we have to think about how to utilize the natural energy that we get from ocean. Ocean energy is good because it's definitely renewable and also we are considered as a very good alternative energy. So if you look at our energy sources, then the ocean energy is going to go into right this little section. Okay, other renewable. It's about 2.3%. So we've got oil, yeah, and then we have natural gas. I'm reiterating your nuclear, hydro, the biomass right there from your garbage, and then your coal. Coal is still right going on this too, and these are something that is current. So technologies of ocean energy, we're looking at the wave, yeah, energy that you can be able to get out of wave. So that's your mechanical, and we can change the mechanical into motion. So it's kind of, the wave itself is your motion. Okay, motion carries the mechanical energy, and we can extract that mechanical energy and turn it into other types of energy. Okay, tidal energy, very strong force. You can turn that into mechanical energy. Yeah. Salinity, gradient energy, the same thing. They are all, I'm gonna draw this again. They are all kinetic energy because they're moving waves, moving tidal, okay? And they've got mechanical power because they come with a force, so that's mechanical energy. And we can use this one, okay? So look at this plant harvesting the ocean energy, okay? And we can use the energy to run the turbines to make electricity, okay, and all the good stuff. And ocean thermal energy, that's a new thing, okay, we call that the OTEC, and we'll get into this details. Something that a lot of the people can get it, this part, but when it gets to here, you probably won't think about it. Yeah, that's your ocean thermal heat. We call it thermal is a heat energy. Here's a wave energy, how to harvest the waves energy. We got 3 types. We call that converter because you convert the energy anyway, or change the form of energy. So first thing that we do is we oscillate the water volume. So that's trapping the air pockets to drive the turbine. Okay. The other one is we oscillate the body converters. That's nothing but just use the wave motion. Again, motion is your kinetic energy. Your overtopping converters, that's like we make use of the height differences. So the height difference is another energy. So that's your, okay, MGH. Always remember that. Oh, that's your potential energy. Okay, and here comes your height. That's your gravity. That's your mass of your water in the ocean. Slow down a little bit here and read little by little. Think and try to understand it. Okay. Oscillating water column, oscillating body converter, and then overtopping the converter and what they are here. And wave energy, in order to visualize, I want you to go to this website and just copy and paste it in your browser. Okay, just talking about the ocean power plant generates the energy by using waves. Alright, it's a good video to visualize what wave energy is and how we harvest. Okay, so tidal energy, again, kinetic energy, motion. And we're going to, harness that, meaning like we're going to use it. So where do we get it? We get it from the surging tides. Your MGH, your potential energy, we play with the height. So differences in, this is not high, this is actually height. HIGHD, I'll change it later after this video. And differences in height and low tides, because your tides are like going like this, right? And then go sometime they are like a very heavy wave like this, yeah, and they have different waves height. Okay, so every time a mass, so this is your water carry mass, so that's your M, and we've got gravity all the time, right, downwards to the core of your earth, and then your height, which is this guy, tip of your tide, all the way to the ground under the ocean, and then your surface of the ground under the ocean, and then the tip of the tide, go all the way down to the bottom of the ocean, and that is the height. You have height 1 here, and then you have height 2 here. So 1 and 2 are just telling you they have different heights. So we're going to play with that to be able to harness, right, the potential energy. Motion, kinetic energy. Try to get it, from the surging tides, and then the potential energy, and we're gonna play with the heights of your tides. Tidal power is nothing but like, since we've got ocean, and as you know, the size of the ocean, the mass of the water in these oceans are very, very huge. So therefore the energy that we can be able to get from them is also very huge. And one thing good about it is, depends on the geological regions all over the world. Your tides, right, are kind of constant, meaning like they're predictable. So therefore we can be able to harness the energy, and that is reliable. Here another video link, and just talking about your tidal power. 101 is just like they just name it, and I want you to go there, listen, watch this, and visualize. Then we're gonna review your maybe I think middle school knowledge, right? So what ocean tides are. So don't forget, like, they're just the very, very long period waves, right? And they can move right through the ocean, and that movement is completely induced, right, by the moon and the sun. The forces exerted by your moon and the sun right here, right? And they cause, right? They cause the ocean tides. And then we're going to get back into our facts. So about your ocean tides, every time you have changes in the ocean tides, they create massive amount of ME, which is your mechanical energy. We call it ME. That's just an abbreviation for mechanical energy. Turbines, very, very large turbines. Right, we can move them by using ocean tides energy. And if you compare to the solar density, we have to know like every moderate wave motion. This is just a movement. So your kinetic energy, and it possesses an energy density, greater. It's got to be greater than the solar density. So therefore we shouldn't take it for granted, the energy, right, that comes from ocean tides, and we got to make our technology be able to harness the ocean tide energy, or I'll just say like ocean energy. Okay. Tidal turbines are nothing but we are converting the energy from the tidal current. So here you have movement of kinetic energy, okay, and this kinetic energy is going to turn the turbine rotor and then the generator unit. So therefore we can be able to get electricity right up here, yeah, and then you can use. These are just a pictures showing you different types, okay, of tidal turbines that you can see. And I don't want you to forget the concept, kinetic energy, motion, right, from the tidal waves, and then we're going to use that, turn the turbines, okay. The turbines, they have blades, okay, so therefore we turn them, and we got the motion, and we got the mechanical energy, and then we're going to use that, right, to produce something, running the generator or whatever purpose that we want to use that energy for. Another design, see many different designs. This is what we see on the surface, yeah, of the ocean. If you pay attention, if you go cruise, and you can be able to see these, right, near some of the country coastal line, and that's what's going on underneath, yeah. And this is another type. This one is they're using the cylindrical rotor, okay, in the systems. And it's pretty depends on what you want to do. The size they vary. Then we'll get into salinity gradient energy. Another renewable energy. Okay, I'm gonna highlight this one here for you. Of course, that's from the ocean, so therefore we got it all the time, yeah. Just like your wind, your wave, and your solar. So today what we've got is RED. So red is reverse electrodialysis. Okay, that's just a system design. And with red, you can harvest salinity gradient energy by using the differences in the salt. Okay, salinity meaning salt. So I'm gonna write that down here as SALT. Gradient. Every time you see this gradient, we are looking at the difference. Okay, difference in the salt concentration. Of course, salt is a compound, right? So they have like this. You know, we can draw salt like that, right? So a mass, a heap of salt, like here. Of course, very large amount of salt in the ocean. So, anyways, the salt concentration. They're mixed with water. Okay, water mass as well. So that salt concentration. We usually hit between the ocean and the river. So so if you think about what's going on inside, so we have anion, right? That's your negative ion, and then there's your cation ion and your positive ions, right? They are alternating. So every time you have anions and cations, we can be able to generate the electricity, right? Because every time you've got ion, it means like they are in the active states. Okay, everything that is in active state, right, in the atomic level, you can get the flow of the negative, right, ion, which is your electron. So therefore, you can get the current flow, and that's your electricity. Okay. So make sure you review your chemistry. Don't forget your charges, and don't forget the level. Don't forget the smaller things inside. Okay, matter. The smaller things inside can be able to move faster and also with more force. All right. And here you can see a little picture right there. So this is what we call the ocean. All right. And then here is your river. Maybe it will go. That's kind of like the bay, and it will go branch out into your river to the land. So right here, you've got the salinity difference, or your salt concentration difference, right? And we use that differences to get this salinity gradient energy, and the system is like this underground, right? You can be able to build it, right? And channel or route the current which is your ocean, and inside there's a salinity concentration in this water, okay, ocean water. Because ocean water is very salty anyway, and every time you've got salt, you have cation and anion. Okay, so if you think about your table salt, that is sodium, so that's the Na, and then your chloride is your Cl. Okay, so when they split in the solution, okay, you've got positive sodium and negative chloride. Okay, and this is what we say anions, and then this is what we call the cations. Yeah. So here, presence of electrons. Here, absence of electrons. Positive means I don't have electron anymore. Active part is missing. Here I've got active electron with me. Okay, therefore I am energized. And you know, electron is very important for current. Okay, these little guys, little particle moves. So that's your anyway, so we can be able to produce the electricity from there. I'm just going to write electricity E here, but don't confuse with energy. We also use the E for energy. This is just trying to tell you about the salinity gradient energy system. So the pilot of facility is by a Fuji film membranes that they use, okay, like that. This is just a cartoon diagram. And Netherlands is currently running, okay. I don't know how to pronounce this one. Anyway, at that location. So again, so where do we get this? A difference in salt concentration. You have your seawater at that location, okay, from the North Sea. And then we got fresh water, okay. Maybe I think this is some sort of river, I guess. And that's where we get the salinity gradient. They're still working on the cost effectiveness. Also, they're working on the membrane, okay, performance improvement. So if you take a look at the diagram, you can see here, okay, there's a Fujifilm membrane, looks like that inside. Okay, what are we doing? Your anions and your cations of your salt from the ocean. Alright, then you will visit, right, this link and watch, right, visualize the salinity gradient energy. And this is just showing you from the blue energy salinity gradient power. This is just a company name, okay? They make this kind of educational animation, okay? And that's pretty unique. And it will definitely help you, right, for your study. And we all use it at all university or school. Alright, then we'll get into thermal, your heat energy conversion, and we call that O, T, and then E, and then C. So every time you see O, T, E, C, you know that that's your ocean. T for thermal, and E for energy, and that's conversion, okay? Here's a little diagram, so you know that how we're gonna produce electricity. Every time you produce electricity, you've got a generator. Okay, the generator got to be run by some form of mechanical energy, and that's we get it from turbine, right? Turbine, they have blades, and we gotta run these blades to get mechanical energy, and that we're gonna use the heat, okay, from the ocean. So if you go down all the way and we got pump here, you know, this is just a recycling, alright, excess heat. And then we're gonna get that back, condense it, right, and then pump it back out, and then we can be able to this is directly from the seawater, and this one is from our excess from the turbine, okay? We recycle that anyway. And this is where we change the heat, okay? Here, use the seawater, pump into our unit. Okay, this is our exchanger unit for heat. Thermal adjustments going on right there. And we're going to have, alright, heated one. And that's your thermal energy. Turn the turbine, run the generator, and we got electricity. Okay, pretty simple design. and we use the 3 major pumps right here. This is just adjusting the temperature, so you always have a cooling system. And here we're using our own cold deep water or deep ocean water, okay, because it's cold. Yeah, ocean water is very, very cold. So here another exchanger, heat exchanger or adjustment unit right there. Heat adjustment unit right here as well. Yeah. So the main point of this system is we use the thermal differences. For salinity system, we use the salt concentration differences. Okay, every time you have differences, you've got you have some form of power, same as that. So if you think about the hurricanes, right, when gases going on, that's a pressure difference, right? Big, huge amount of pressure, and then low, okay, small amount of pressure in a particular location, and they make imbalances. And our nature has a has a tendency to balance the imbalances, right? Every time they try to balance that, you got forces in terms of wind, forces in terms of water in the ocean, so and so. Okay, so anyway, so we use heat differences in this system, okay? And that heat differences is in the ocean. And from that difference, you got some form of energy, run the turbine, create the electricity. And don't forget about the pumps, right, from your previous diagram. And here in this diagram right here, so I'm going to circle this for you, and right there, yeah. So pumps, they're very important, and they maintain the low pressure. So this is one pole of your pressure difference. Low pressure in your evaporator, which is your exchange unit. So where the warm surface water, right, is going to flush into the evaporator, and then we're going to direct that into the turbine. So make sure you get that system connection. So here we're going to reiterate the whole thing here. That's your cold water intake. Your turbine here, your generator here, okay. Power cable, your electricity coming out from there. From this generator, we turn mechanical to electricity. And here is your liquid, which is your fluid, vapor coming in. Vapor meaning like you've got steam in there, yeah. And that's your ocean surface, and here is my pump. And this is your hot unit, and that's your cold unit to balance the temperature, adjust the temperature. And your mixed water is going to return back into the ocean. Okay, here is your outlet. Okay, ocean, right here, ocean thermal energy, okay, conversion, OTEC. And in this diagram, we are highlighting right here the temperature in values, 80, and here 40 degree Fahrenheit, and we've got 73 degree Fahrenheit. Okay, so we can clearly see the temperature differences. This is low temperature, that's high temperature. And here we've got turbine. Okay, I'm gonna circle this for you so you can see. And this is your generator, okay, right there. We also have a condenser, your evaporator right here, making it steam, which is your vapor, right, turning the water into gas, yeah. And this is your fluid line right there. Okay. The colors are just showing you like this is cold and that's kind of warm, yeah. And this is another type, another configuration of your OTEC system. So we can build OTEC system plant, right, onshore. And you can also build offshore. Offshore got to be got to be the floating platforms, okay? The energy we're gonna transport, right, using the cable. As you know, electricity, it runs on cable, so therefore you need cable to transport the energy we created by using the OTEC systems. And they try to locate, alright, the OTEC system location not so far away from your electric grid, okay? so you don't have to use a lot of money for transportation, okay, of electricity, because cables are metal and they're very expensive. Just showing a picture of the old-type plant in Hawaii, okay. Then we'll get into pros and cons. So for pro, fresh drinking water, we can get it by condensation of steam in this system. And we can also use a cold water steam, alright, from OTAC for air conditioning or refrigeration. We can extract the sea salt. Everybody loves sea salt and minerals. And cold water steam, they're pretty good because they've got nutrients, right? We can use in agriculture and also mariculture uses. Mari is nothing but concerned with your ocean, alright? This is concerned with your land. And OTAC is pretty new, so therefore the drawback is we're still researching. We're trying to make technology better, so therefore we're still in the experimental stage, okay? Your turbine, here, generator, okay, here, your evaporating chamber, which is your exchanger unit, exchanging water, of course, into steam. And your pumps, yeah, your inlet, okay, excess. We have another exchanging unit right there for condensation, okay, evaporation here, condensation here, yeah. Evaporation is nothing but changing water into, I just write a gas, which is liquid, yeah. In chemical way, we go L to G, water to water vapor, okay. And here you condense back into water and then get it back into your ocean. So we've got excess vapor coming in, turn it back into water, okay. We use the temperature changes, which is your heat changes. Another video, I want you to visit this website and look at it about the ocean thermal energy conversion, okay? Okay, then we'll continue our pros. That's your advantages. The first thing is you have a low visual impact, mainly, okay, but not totally submerged. Low visual. And second one is your low noise pollution. So that's a pretty good thing. Low noise pollution, it's kind of like your sound level is transmitted, okay, but at a very low level, yeah. So therefore, low noise, meaning sound level transmitted are very low. High predictability, we can predict because we know our currents, we know our tides, yeah. And definitely tides are not like wind. Wind is kind of like surprise attack all the time, yeah. And you also have high power density. So smaller turbines, you can use you don't have to use very big turbines for this system, yeah. So if you want to compare it to the wind turbine, we use the same power, but we can go with smaller turbines for OTEC systems. Disadvantages: high maintenance costs, of course. So money, not very good. We have high power distribution costs, okay, because of the cable again. Limited technology capacity because it is still in developmental or experimental stage, okay, this technology is. And we can expect the intermittent power generation, meaning like we can't get constant power out of this system yet. Okay, so these are just links, right? Video links, and don't limit yourself, right, to these links. There are thousands and thousands of videos out there. Just Google it and then study with them, alright? Some of them are very, very good. But again, make sure you base your handout and textbook for quiz and final, right, exam. Alright, I'm gonna go ahead and end here.